Hi boys and girls, we're going to go over equivalent fractions for your lesson on Wednesday, May 6th. So let's get out your workbook to page 83, and you have hopefully already corrected your work with the answer key. And now we're just going to go through and make sure everybody understands what's happening so that next week we can build more, okay, on fractions. So looking at your workbook, if you don't have it, pause it and go get it. The first three questions, if you remember from our video yesterday, we looked at simplest form fractions in two ways. We used the manipulatives and the different shapes to show us different fractions for the same area. And then at the end, we did one where we lined up our fractions and we used division in the numerator and the denominator to shrink our fraction down to the simplest form. So your workbook page basically used both strategies. In 1 through 3, it was like the bars. So for number 1, you can see with the bars that there's 1 2/10, 2 in the numerator, 10 in the denominator. Okay. For number 2, if you count all of those little twelfths, there's 9. So you would put 9. Wes, can you quiet down back there? Wes is having some popcorn. It's loud. Okay, so there are 9 twelfths. So number 2 is 9 twelfths. Number 3, if you look at the teeny tiny little tenths, there are 1, 2, 3, 4, 5. So we put 5 in the numerator. 5 tenths is representing the same area or the same part of the whole as 3/6 are. Okay, so they're equivalent fractions. They're equal. Different fractions, equal because they're covering the same part of the whole, okay? Looking at 4 through 6, we're getting the simplest form with using the operation of division. The tricky part is figuring out what's the divisor. What number can we divide into the numerator and the denominator to shrink our fraction down to the simplest form? So if we look at number 4, we start with 3/12. And if you line it up like this, it's helpful. Get your fraction, okay? And then you decide which number can be divided into the numerator and the denominator evenly to shrink our fraction down to simplest form, right? So if we have 3/12, I line it up and I say 3 divided by 3 equals 1. And then I have my numerator. I'm going to put my line in there so that I know I'm still dealing with fractions and I have everything separated. 12 divided by 3 equals 4. So I shrunk that fraction down to an equivalent fraction of 1/4. Okay? So your answer for number 4 should have been 1/4. Same strategy for the next one. We have 8 tenths. What divisor, what number can we divide into the numerator and the denominator that will divide them both equally? 2 works great. So 8 divided by 2 is 4. For the numerator, and 10 divided by 2 is 5 for the denominator. So we end up with 4/5. Okay? So we shrunk that down to the simplest form. All right? Number 6 was a little bit different because it has no common divisor between 3 and 8. So what we have to do there is say, oh, this is the simplest form. So you would have written 3/8 for the simplest form on that one. We couldn't shrink it anymore. All right, so looking at number 7, Rob covered 1/4 of a rectangle. What's another way to name 1/4 of that rectangle? Okay, so he has a rectangle divided up into 4 equal parts. And how else can we name this? Well, one way to do it is to divide it up again into equal parts. Like for me, it would be easiest to jump from 4ths to 8ths and divide all these 4ths into 8ths. So in that case, let me do that. All right, now I have 8 pieces instead of 4. I doubled it. And Rob colored 1/4. So for us, that would be a section like this. And we can see that now the fraction is 2. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. 2/8. Okay? So another way, or an equivalent fraction for 1 fourth is 2/8. Okay? All right, so that's one way to think about it. All right, number 8. 3/5 of the cast in a musical have to sing. What fraction of the cast does not have to sing? Okay, well, how do you figure that out? If you got the answer 2/5, you were correct. But if we've got 2/5, all right, so the information we know is 3/5. 3/5 of the cast in the musical have to sing. What fraction of the cast does not have to sing? Okay, so who's left over, right? If we know in the denominator it's the total number of parts, or in this case, cast members, there's 5 cast members, and 3 have to sing, we know there's 2 left over. So that fraction is 2/5. That's how you figure that one out. Hopefully you were able to do that. Okay? Now, in number 9 and number 10, we're looking to complete the pattern. Okay? So we're almost, instead of making our fraction in the simplest form and working backwards, we're adding on and going up in a pattern for our fraction. So for number 9, if you follow the pattern, you get 4/12. Adding on, in number 10, we get 5/10 and 6/12. So if you see those patterns in the numerator and the denominator, and you just continue those on, okay? Great. Now, I want to go over number 11 because often we see that explain it and everyone panics, right? So let's see. When using fraction strips, those are our manipulatives that I showed you in yesterday's video, how do you know that the two fractions are equivalent or equal? Okay. So remember in our video yesterday, I kept showing you that they have to share the same area. They've got to cover the same area. If a fraction strip goes over the edge, it's not covering the same area. It's not a good fit. It's not equivalent. It's not equal to. Okay, so a good answer here would have been something like if the fraction strips fill the same space, or if they align on the left and right side, that would have been a good answer. That means they're equal to. Or if you said something like these strips have to cover the same part of the whole, that would work too. So basically all they're asking is, how do you know that the two fractions are equivalent? Well, they have to equally cover the same part of the whole. The numbers and the fractions can be different, but they have to equal the same area. Okay, that's how you explain that. Okay, so let's see. Last one. Samuel has read 5/6 of his assignment. Judy has read 10/12 of her assignment. Their assignments were the same size. Which sentence is true? Was it A, Samuel read more than Judy? B, Judy read more than Samuel? C, they read the same amount? D, they will both finish the assignment at the same time? Well, the answer here is C. And the reason that we know that is if we know that their assignment were the same size, then we know that that's the same amount, equal to. Even though the fraction numbers are different, they can cover the same area, and that makes them equal to. Okay, so C was the answer. Now, we're not going to meet on Friday Zoom, so we're going to have Zoom today. If you have any questions on this, we can talk about them then. And thanks so much for your great listening, and I'll see you guys next time.